I think we should do one more. Just one more. No, we'll call it a night. Been very productive evening. We've done that by chance. Does it look familiar? No? Okay, I'm going to let you go on your own. We know FRE, let's see. She could have many friends. She respects them as individuals. Did we ever discuss this?
Yeah.
Only if? No, it's not a tribar.
It would be a backwards conditional statement. Or
We did discuss it,
reverse.
didn't we?
Yeah, reverse.
Listen. Only if introduces the consequent of a horseshoe. The consequent. If introduces the antecedent. Didn't I have that on the board at some point? Sufficient and necessary? Uh-oh.
Yeah.
I did, huh?
Yeah.
The antecedent of a horseshoe is said to be sufficient for the consequent. The consequent is said to be necessary for the antecedent. That's what a horseshoe means. The word only if means is necessary. Only if. See? There are humans on Mars only if there's oxygen. So oxygen is necessary. But that's the consequent of a horseshoe. All right, go. Are you done with your translation? How many people negated E twice? It's not necessary. It wouldn't be wrong, but it's not necessary. Because we see that E, for all we know so far, she can't expect them all to behave alike. Only if we found the statement she does expect them, would one of them have to be negated. But it doesn't happen that way. And by the way, it can't affect the validity or invalidity of the argument, either translation. I think we should go ahead and knock out an 8-row long truth table. It's the longest you'll have to do on the test. We're going to Q2, right? That's where you get your 8 from. are my initial guide columns. Does that look right to you?
How do you get E?
Our formula. Two is always the beginning. You raise it to the power equal to the number of unique simple statements. We have three of them, F, R, E, right? The first thing the formula tells you is how many rows you're going to have. 8. Then you start dividing by 2. The first division tells you how many you're going to alternate T's and F's by under the first unique simple statement by 4, beginning with T. So that would be in our case F, right? You divide by 2 again. That tells you how many to alternate T's and F's by under the second simple statement. In our case, R, beginning with T. T, T, F, F, T, T, F. Okay? You divide by 2 again. There you go. So what do you think? Is that what you have for your initial guide columns? Okay. Go ahead and finish it off. First premise.
Can we go back real quick?
Oh. Yeah, did I make a mistake again? Looks good.
Or maybe I wrote it wrong. Look at the problem. It's F first or R first on the formula?
Oh,
R first. F is first, right?
no, R is first.
R is first.
Because the way it's written.
Right.
Wait.
Backwards.
You talking about this?
Yeah.
Friends.
Only if refers to the consequent of a horseshoe.
Right.
This is the consequent of the horseshoe.
So it's F first, right?
Yeah.
Alright.
Oh, yeah. Complete table. I'm going to draw a line down columns I'm not concerned with at this point. Only checking the truth values for the premises and the conclusion, not their components. What is,
Oh, never mind.
you sure? You caught me once before.
No, it's okay.
It's okay.
Doesn't the if introduce the antecedent? when
Yeah.
it's- Yeah, but isn't that only when it's the 3-line one?
No.
So if is not the antecedent, it's included?
If introduces an antecedent to the horseshoe. This says only if.
But there's no only if in a horseshoe, is there?
I'm telling you.
Or is only if universally a consequence?
Yeah.
So the
Because
only if is
only
universally a
if-
consequent
Only
regardless of
if
what
means
term.
this is necessary.
Okay.
And it's the consequent that is necessary
Okay.
for the antecedent. So only,
Okay.
and the author tells you this when he introduces the horseshoe.
No, yeah, you told us that and I wrote it down. I just thought it was only related to the tree bar.
No, try bars if and only if.
Right. Okay.
What do you think? nothing. Here, I'm gonna show you a shortcut. Those are the only rows I really have to check. You know why?
It's the only row that the conclusion is false.
Because I'm looking for rows on which all premises are true and the conclusion false. Therefore, I only have to check rows on which the conclusion is false. Agreed? Let's go ahead and have a look. 8. Six is good. 4 is good. 2 is good. There are no rows on which the premises are true and the conclusion false. What do you think about that?